Okay, so now moving on to module number 13. It's about the general normal distribution and the central limit theorem. Okay. So the average height of 9th grade girls is 60 inches and standard deviation is 5 inches. Assume that height is normally distributed. What percentage of 9th graders are less than 60 inches? Okay, so we know the average is 60 and the standard deviation is 5. What percentage is less than 63 inches? Okay, so here in the center is 60, here's 63, less than 63 is back here. Okay, so this is the distribution of x, right, general normal. I need to bring that to the distribution of z, which we have a table for. Okay, and so how do I do that? Centered on 0. When I do that, I use this formula, z equals x minus mu divided by sigma. Right? So that is 63, that's the number I'm trying to transform. Mu is 60, sigma is 5. 3 divided by 5. Okay, 0.6. I'm still looking for this back area. These two shaded in areas are the same, right? So I just need to find that area, the probability that x is less than 63 is exactly the same thing as z is less than 0.6. Okay, so the z is 0.6. Here we go. 0.7257. Okay, so based on that calculation, is it unusual for a 9th grade girl to be less than 63 inches? No, right? Not unusual, because 0.7257 is more than 0.05. Remember, 0.05 is our cutoff for unusual. Okay, so it's quite usual. More than half of the girls are less than 63 inches, right? 72% of them are less than 63 inches. Okay, find the probability that a 9th grade girl is between 57 and 63. Okay, so this is a between probability. Okay, so first thing we need to do is change that over into a normal distribution, find the corresponding z's cutoffs here. Okay, so starting with 57, so x minus mu, 57 minus 60 divided by 5, that would be negative 3 divided by 5, which is negative 0.6. Okay, we already found for 63 the corresponding is positive 0.6. Okay, so the probability that x is between is exactly the same as the probability z is between negative 0.6, positive 0.6. Okay, so remember to find between probabilities, we find the probability that z is less than positive 0.6, which is this area back here, and then we subtract off probability z is less than negative 0.6. This area back here. Right? If we take this and subtract off this, we're left with the between. Okay? Now, this one I already looked up. This one I need to find. So I go to the negative side of my z table, look up negative 0.6 right there, 0.2743. Okay? So 0.7257, 0.43, okay. That's my answer. Alright, find the 68th percentile. So remember, percentile means percentage that's less than. So 0.68 is less than whatever this cutoff value is. Okay, so let's first find that corresponding Z 68th percentile. Okay, so I look inside my table for 0.68. So let's see, 0.68. Remember, pick the one that's closest. That's 0.0008 away, so that's close, really close to 0.68. 0.47. Okay. So now, to find the corresponding value on the distribution of x, which is centered on 60, I know that my answer should be more than 60, right? I just need to figure out how to go from here to there, right? So I need to basically rearrange this equation and solve for x. Okay, so I know, so I have this equation, z equals x minus mu divided by sigma. I know z now is, z is 0.47. I do not know what x is. I know that mu is 60 and sigma is 5. You multiply both sides by 5. Okay, and then add 60 to both sides. Here. So x equals 60 plus, okay, so let me go ahead and calculate that out. 60 plus 0.47 times 5, 62.35. Okay, so this number is 62.35. 68% of the 9th graders are less than 62.35 inches. All right, last type of question for module for the module about the normal distribution is the central limit theorem type questions. Okay, so 35 9th graders are randomly selected. Find the probability that the average height, okay, so not the probability for a randomly selected 9th grader, but the probability for the average height, there's a typo there, of the 35 girls is more than 62 inches. Okay, based on this calculation, is it unusual for the average height of 35 girls to be more than 62 inches? So more than 62 inches. Okay, so 60 is still in the center. Here's 62. Right, instead of this being the distribution of x, this is now the distribution of x bar. Okay. So when I change this over to the distribution of z, I need to use the central limit theorem formula here. How do I know I'm using this one and not this one? Because I'm trying to find a probability for the average, not probability for a single person. So I have x bar here. X bar minus mu sigma over square root of n. So x bar is 62. Okay, mu is still 60. Sigma is 5. Square root of 35. Okay, so let's see. That'd be, let me go and do the denominator here first. So 5 divided by the square root of 35. Oops, okay, so that's the denominator. The numerator, I have 62 minus 60, which is 2. So I'll do 2 divided by the answer. Okay, and I get 2.37. Notice that that's 6. We'll round that to a 7. Now, all z value is always rounded 2 decimal places because my table only has 2 decimal places. Right? My table only has 2 decimal places. Alright, so now I'm trying to figure out what this area is. Alright, if I look up 2.37 in the table, 2.37, 0.9911, is that my answer? No, right, because that's this area back here, 0.9. 911 is the area back here. If I want to know the probability that the average for 35 girls is more than 62, then I need to do 1 minus that. 0.9911. Okay. So the probability, I have it written up here. So this equals 0.0089, which is what this area up top here is. Okay. Is this unusual? Right? So yes, this one is unusual. It would be unusual to get a sample of 35 girls and have their height be more than 62 inches, right? So yes, unusual because 0.0089 is less than 0.05, which is our cutoff for unusual. All right.